Welcome to the IIQ for Building Automation webinar. And my name is Phil Zito. For those of you who don't know me, you should be seeing me right now, but that's me back when I had a little bit more hair. I am the CEO of Smart Buildings Academy. We are the fastest growing provider of building automation training in the world. My background is in systems integration, cybersecurity, BAS installation and service, sales, ops. I've done a little bit of everything as I've moved through this wonderful career field. I've written for the ASHRAE Journal. I've written a book, done a bunch of podcast episodes, created about 15 courses that total about 600 hours of training content. And kind of my hobbies, things that are interesting to me, are reading, doing jujitsu, spending time with my kids, working out, things like that. So that's a little about me. Here's what we're going to be discussing in today's webinar. Now, I will preface this webinar with saying, like many of you all, I have children that are not in school. And so it is entirely possible that there will be banging on the door at some point as they start fighting with one another. They seem to have some internal sense of when dad is doing presentations, that is the time to fight. So I apologize for that in advance if that happens. That being said, our topics we're going to cover are: what is indoor air quality? We're going to talk about what this is, why it matters. We're going to go through methods of indoor air quality control. We're going to talk through kind of what are the most basic of methods. I thought about going deeper than that, but then I started to realize a lot of questions I get are more on the basic side, which that just stems to be true about most things. We're going to overview some common IAQ technologies. We're going to look at changes to IAQ control during COVID, and we're going to have a live question and answer session. All right, so what is indoor air quality? Indoor air quality, quite simply, is the quality of the air inside the building. I mean, obviously, right? Now, traditionally, this was defined by the control or absence of variables that affect health and comfort. And I really want to highlight that comfort piece because what we're going to see in a lot of the ASHRAE recommendations around COVID-19 mitigation strategies, they focus on the outside airflow, but if you read into them, they also focus in on comfort as well. Because the reality is, you can take those control strategies to the letter and actually induce a very uncomfortable environment within a building. Additionally, you can go and actually create damaging environments within your building, not just to the occupants, but to the building itself. So when we look at IIQ, we are looking at things like temperature, humidity, CO2, volatile compounds, etc., CO, things like that, right? Now, with the recent rise of COVID-19 and the focus on that, viral load and spread are now being seen as threats to occupants. I say they're now being seen because, the flu, all that stuff was a threat to occupants in the past, but now we are a lot more focused on viral load and spread within a building. So this has led to the creation of some new control recommendations, most of which we'll go through today. The ones we don't go through, I will point you to the resource that you all should read if you haven't read yet, and it'll take you through kind of the guidelines of what to do in response to your building and how to properly condition it. All right, so why does this matter? Why does this indoor air quality matter? Well, I gave you a couple reasons earlier, right? It affects buildings and occupants in many different ways. First, it affects the health of the occupants. And you're gonna notice kind of the hierarchy I put in here. It's my opinion on the hierarchy, but it's an opinion based on experience, which is obviously the health is going to come first. Life safety is going to come first. If we think about, just as building automation folks, if we think about our priority index, what's top of the priority index array? That's health and life safety, right? Because our control sequences, how we operate our building, should primarily be focused on the health of the occupants. That should be our primary focus. From there, and this is where some folks will disagree, I say that we should focus on the comfort of the occupants. We've got a lot going against us trying to get people to reoccupy buildings. The last thing we want to do is create an uncomfortable environment, because if you could be like me right now, sitting in my basement where I have the AC set at 67 degrees because I like it really ice cold, and then I'm forced to go into a building that's implementing some sequence that is making it 75 degrees and 60% relative humidity, I'm going to be uncomfortable. I'm not going to like that. And if I don't have to go into that building, I'm not going to go into it. So we want to look at the comfort of our occupants in everything we do. And then finally, the health of the building itself. Now, this is why I said some folks will disagree. They will say the health of the building comes before the occupant's comfort, and some folks will say it comes after, like I do. The reason I say it comes after is, yes, you want to make sure you don't have excess humidity so that you have mold buildup. You don't want to run your equipment into the ground by implementing, MERV 13 filters, and then the pressure drops so high that your fans are running full speed all the time and you simply are just burning your systems into the ground. That being said, if you have the most perfect, well performing building in the world, it doesn't matter if you don't have people in it. So if you can't get people to come back, that's why I say the comfort of occupants should be our secondary focus of IAQ. Speaking of IAQ, how about AQI? A lot of folks have never heard about this, and it's incredibly important. I mean, just think of the West Coast right now. Would you be going and implementing a outdoor air centric strategy if you're in Portland right now or Northern California? Probably not. The indoor or the outdoor air quality, the air quality index, is pretty terrible right now, to the point where I have family who lives in Portland and I have family that lives in Sacramento, and they are wearing masks inside their house because the infiltration of the, I guess you would call it PM10, particulate matter 10, is getting into the house and causing the air to be very unhealthy. So understanding AQI is very important, because if we are implementing a lot of the ASHRAE recommendations, which have a lot to do with outdoor air intake, then we're going to find that the healthiness of our air is centric to us implementing those strategies. So we really need to be cognizant of this. This is something that we need to be aware of. I will say, as a industry, we've done a poor job, short of taking RESTful weather station API data and pulling it into our BAS. We've done a poor job of collecting this data and building it in to our sequences. I mean, and you all can just write this in the comments, but how many of you have actually seen a specification where IAQ data is pulled in and is brought into the building automation system and is driving the economizer decision, whether or not we turn on economizer? It's not a very common strategy. Normally we look at dry bulb temperatures. Sometimes we look at enthalpy, but very, very rarely do we look at IAQ. I see this a little bit in hospitals, but it's oftentimes a manual shutdown switch that actually overrides outdoor air intake based on a event outside the hospital. And they say, oh no, a chem truck exploded right outside the hospital, so we're going to go and push this button and shut down all outdoor air intake. It's very rarely a data feed that's actually brought into the system. All right. That being said, at the end of each of these sessions, I'm going to have some key points. And these are kind of what I want you to take away. The first is IAQ is only as good as your measurements. I firmly believe we're moving into a retrofit market. The capital construction market seems to be collapsing around us, and it's kind of difficult to make an argument to build a bunch of new buildings when you're having trouble occupying the ones you already have. So with that being said, I feel like we're going to enter a actual retrofit market. And with this retrofit market, it's going to be driven by actually having data. Now, IAQ, when we want to drive it, whether it's ASHRAE 62 or ASHRAE 55, which is thermal comfort, and we're driving temperature, humidity, CO2, et cetera, it's only as good as your data measurements. So just because you have humidity sensors or CO2 sensors does not mean that those elements are still valid. I mean, if you haven't checked those for calibration in several years, then those elements actually could have degraded and those sensors could be pretty close to useless. So it's only as good as your measurements. AQI should not be ignored. It's not easy data to bring in. It's really not. A lot of systems don't have a way to consume RESTful API data, especially legacy systems. And a RESTful API is basically a data feed from a weather station. And it's the most common way you would pull the data in. So how do you do this? Some of it's going to be retrofit. Some of it may be something like a protocol gateway that does some sort of conversion. But if you can get this data in and use it to drive your economizer decisions, you're really going to improve the health of your buildings. I'll tell you a story a little later about an AQI issue that had at a previous site. IAQ and AQI are linked. Hopefully you believe this by now in the presentation. If you don't, please message me because they are. If you're not considering the outdoor air quality that you are bringing into your indoor air quality, then you are missing a huge opportunity for improving the indoor air quality. I'm going to take a sip of water real quick. All right. Common IAQ control strategies. All right, let's take a look at these. The first of which is demand control ventilation. It's controlling outdoor airflow based on actual CO2 loads. There is minimum outdoor air intake, and this is basically what you're going to see in most buildings. And this is actually something that ASHRAE is recommending. So ASHRAE is not recommending DCV right now because of the variability of outdoor airflow. But if you are having problems dealing with that enthalpy load being introduced by humid outdoor air, then they are recommending to step back to the ASHRAE 62.1 standards. And then building space and pressurization. And these are strategies to control positive and negative pressure within spaces, usually done through volume changes on the main air handlers, sometimes done at boxes if you have dedicated supply and exhaust boxes in each space. So let's go through. Demand control ventilation, what it's going to do, and I've kind of boldened on some of these slides the inputs and outputs and set points. But demand control, man, if I could speak, demand control ventilation utilizes local CO2 sensors, typically in the return duct or on a space wall. Problem with having them in the return duct is if that unit turns off, you have no air drawing them through. So you've got a kind of less reliable value in unoccupied scenarios. That's why I usually like to have them in the space on a wall, if possible, but not every space actually can accommodate that. So you sense the CO2 buildup, and then the building automation system, sometimes smart equipment, sometimes a building automation controller. It's going to drive the outdoor air damper. This is a proportional damper. And right, this is a mixed air unit. This is not going to be 100% outdoor air, because if it's 100% outdoor air, then you have 100% outdoor air. So you're not doing any demand control ventilation on it. So you're going to have some proportional damper on a mixed air unit, and that proportional damper is going to be opposed to the return air dampers. So they're going to have an inverse signal command. And then you will have your CO2 set point, and that CO2 set point is going to be what we drive towards. Now, here's some code I wrote up this morning. You'll see kind of the approach. You got a PID loop, got a occupancy command enabling the PID loop, which I always recommend you enable your PID loops based on occupancy or state. So you have stateful loops so they don't wind up and wind down. And you've got CO2 coming in, you've got your set point, and then you have a linear inverter. Some will call this a scalar object, some will call it a reverse or a negate object. The reason I do that and I don't negate the output, the reason I actually have this converter here is because you want to write your program for the most basic person who's going to use it. So if I have a facility operator who maybe doesn't understand how to really work with the building automation programming software, I'm not going to trust that he knows to click or she knows to click in to the return air damper output here. I am going to invert it here and not in the output so that it can clearly be seen that I am doing an inversion. And the whole purpose here is that you've got your outdoor air command, and then the return air damper will be reverse. With this kind of scaler, you don't have to worry about high or low limits because this PID output on this programming software, at least, is never going to drop below 0 or go above 100. All right, let's take a look at minimum outdoor air intake. So ASHRAE 62.1, if you haven't heard about it, it is a standard, excuse me, my throat's a little dry, that dictates the minimum outdoor air CFM based on space type, occupant count, or square footage. So there's a table kind of, I think it's like page 70 of the standard, little about 2/3 through the standard. And it dictates out a bunch of different space types. And it says based on CFM per occupant, CFM per square footage, or just a round space type number. And then it says, okay, this is the minimum outdoor air flow, and this is the minimum overall flow. And what happens essentially is that the test and balance tech is going to run a system at full flow, and then they're going to set the outdoor air damper minimum position. And then the building automation professional is going to take that value and put it in the BAS. Or if it's a smart equipment, then it's just going to be put in the equipment under one of the AV values, analog values. The variables typically are outdoor air damper proportional command and minimum damper position set point. So you'll go through, this is pretty easy to code, pretty easy to set up. Real simple. Most of the time, I do this in conjunction with mixed air temp for economizer. So you'll see, right, we have a mixed air temp and mixed air temp set point. And what that's going to do right here is that is going to take this right here, and I actually realize I have a code error in this. As I read it, I'm like, oh, that doesn't work. That switch should actually be somewhere else. But whatever. I could draw on it while I do this. But what would happen is mixed air temp going into the PID loop and mixed air temp set point, and then an occupied command. And oh, no. Yeah, it is wrong. I would have to put a maximum block right here, but whatever. So the minimum position would go into a max block. The PID loop would go into the max block. It would take the higher of the two, and then it would take that when it's occupied. And when it's not occupied, it would take an actual off value, a 0 value. Still goes into the linear comparator and then drives these right there. All right. So that is how you would do basic mixed air temp with a minimum outdoor air damper position that is set by the balancer. The reason you're going to do that is typically we're using economizer to get some free cooling. So we're going to drive to our mixed air temp and our mixed air temp set point with the economizer, and we're going to take the lower of or the higher of the two outputs, right? So a max block. And that will make sure we are always at our minimum outdoor air damper position when we're in occupied. Okay, let's continue along. Building and space pressurization. So something we hear about a lot throughout this presentation is going to be air changes. So we're going to focus in on air changes, both for COVID mitigation strategies, as well as just for general pressurization strategies. So for those of you who don't know, an air change is known also by the term air change rate. And what it basically is the measure of the air volume added to or removed from a space divided by the volume of space. That's the air change rate. And an air change is simply replacing the entire cubic volume of air within the space. So you hear like 3 to 4 air changes an hour for an average space. You'll hear 20 to 30 air changes an hour for an operating room. And how we control that is we will often use pressurization within our spaces and buildings and that will create a positive or negatively pressured space. Positively pressured space pushes the air outside the space. So you'll see this in ORs where we want to push the air out of the operating room into kind of the standby corridor where they're staging all the surgery gear and whatever it is they do. And then we have negatively pressurized spaces. You'll see this in isolation rooms where we don't want the air to escape from the isolation room. And usually those rooms will have a dedicated exhaust. Now, as part of this process, we can also increase or decrease air change rates because if we are exhausting more air in a space or we're supplying more air to the space and forcing it through the exhaust, then we're changing the volume of the air. And the faster we change the volume of the air, the faster that we will have air changes. That'll become important when we look at the mitigation strategies around outdoor air and humidity later in this presentation. Excuse me. All right, so this is a basic volumetric offset, and this programming is right. But this is a basic volumetric offset program. You've got supply flow and supply flow set point going into a PID loop. You've got occupancy driving the supply fan and exhaust fan commands. You've got the 0 to 10 volt signal to the VFD driving the supply fan and the exhaust fan. And you've got this exhaust flow over here, and you've got a set point going into a subtraction block, and you've got that subtraction block providing a volumetric offset. So this would create a positively pressured environment because you're going to be supplying more air than you're exhausting. If you wanted to create a negatively pressured environment, then you would simply exhaust more air than you're supplying. That's the basics of building and ultimately space pressurization. All right. Key points. So the first, demand control ventilation enables dynamic control of outside air intake. Let me have another sip of water. All right. So the key point with this right here is that you can do dynamic control of outside air intake, which really is nice in that you can control CO2 loads as needed. This does not work with the ASHRAE guidelines. This is the one thing that they really explicitly exclude from their recommendations is demand control ventilation. Minimum outdoor air intake is a viable solution. It is viable. You hear so many folks who sing the praises of demand control ventilation, and granted, it is good. It is nice. It can save you energy in large spaces. It can reduce how much air you have to bring in the building. That being said, minimum outdoor air intake is still viable. All right, and finally, pressurization and flow can be used to drive IAQ. I am going to have some more water real quick. Should drink a ton of water before this presentation, but I didn't even think about it. All right, common IAQ technologies. First, needlepoint bipolar ionization. I'm sure a lot of you have heard about this. MPBI. So it's kind of a mouthful. Basically, in a nutshell, it's going to ionize some particles, and these are going to attach themselves to pathogens and starve the pathogens of hydrogen. Then we have ultraviolet lighting, and this is going to use light on the ultraviolet spectrum to kill pathogens. And then we have filtration, and this is going to filter pathogens and other fine particles, PM 2.5 and PM 10, from the airstream. Now, needlepoint bipolar ionization, and that's like the only image I could find, and it's a space-based ionization piece of equipment. I couldn't find any non-copywritten images, unfortunately. But basically what it looks like is almost like a mist-based humidifier. It's got these little kind of discharge nozzles that allows you to ionize the airstream. Now, the nice part about this is that These ions, right, as they attach to the pathogens and they kill them by starving of hydrogen, they are doing that to high velocity airstreams. So that's kind of nice. That is dealing with one of the weaknesses of ultraviolet, which is that ultraviolet needs exposure time versus ionization can actually deal with a moving airstream. So it's worth noting, though, if you have a system from early 2000s or earlier, they did produce ozone. They've pretty much eliminated that with the newer technology. So it's not really a concern anymore. Now, needlepoint bipolar ionization. While MPBI has been shown to reduce pathogen loads in the airstream, there are three factors that must be considered. And I cannot tell you how hard it was to find this because everything I read sung the praises of MPBI. I mean, literally, you would think this stuff was like gold plated, amazing cure alls. But there actually are a couple factors that you need to consider. And those are first, is the pathogen load even in the return airstream in the first place? We've all been to buildings, or maybe you all haven't, but I've been to plenty of buildings where, due to poor design, the supply duct was right next to the return duct. Sorry, I have a really dry throat today. I think the humidity is dropping, and that's probably the problem. And I do not have a humidifier in my house. So that being said, the return airstream and the supply airstream, when they're too close to each other, like you can't see it, but my supply duct is right up there and my return duct is way back there. So I actually get some decent mixing here in this room. That being said, in certain spaces, you don't get that mixing. Or if it's a high plenum or a high return, then the pathogens may not be captured by the return airstream. And if they aren't captured by the return airstream, then this technology is really just filtering the outdoor air and whatever it's getting out of the ceiling. So you need to be cognizant of, can I actually get good flow through my space? And I'm going to do some really basic drawing real quick. But basically, supply duct, exhaust duct, can I actually get mixing down here at the floor level? And if I can't, then this technology is not going to be as effective. So you don't hear people really mention that quite a bit, but it's something to be aware of. The second is it does not sterilize surfaces. So the jury's still out about whether it's a high vector of transmission through surfaces or if it's a high vector of transmission through airstreams. You can find studies for both. You can find studies that say it's completely air. You can find studies that say it's completely surface. I'm not an expert on that, to be completely honest. I just know that MPBI does not sterilize surfaces. So that being said, be cognizant of that. That's where some of these UV treatments come in play, and we'll talk about that on the next slide. And then finally, is the MPBI system set up to appropriately handle the airstream as the reach of the MPBI system can be limited? In extremely long or large systems, the ions, from everything I've read, can disperse pretty rapidly. So if you have a long run, you may have to lay out your system differently because it's not going to handle a long run. So be cognizant of where you place the system within the airstream. All right. Ultraviolet lighting. So UV lighting works by using light across the ultraviolet spectrum to kill pathogens. Now, the downside of this lighting is that it requires a period of exposure in order to sterilize objects. Now, that's fine if you're sterilizing a coil or a filter, or if you're doing spot sterilization of a space. It's not necessarily applicable to sterilizing an airstream. And that's why you'll see a little bit later in this presentation, I say that IAQ technologies are really a combined strategy. So when we look at UV lighting, typically what's going to happen, right? It's implemented in the air handling unit close to the return ducting, and then it's utilized to sterilize coils and filters. Now, the UV lighting, it's usually enabled via an always on circuit, meaning if the system's on or if it's off, meaning the air handling system, the UV lighting's still going to be on. Now, because UV lighting is dangerous to humans and exposure can lead to burns, the UV power circuit is typically routed through a set of door contacts, which disables the UV lighting if the doors to the equipment are open. So that's typically how it works. Now, installing UV requires the space within the unit to mount the lighting. That being said, these things aren't super big anymore, so you can usually fit them in most built air handlers. Rooftop units, you probably have a little bit more trouble. UV can also be used for spot-based sterilization, and supposedly, it is being included more and more in some lighting fixtures for unoccupied space sterilization. I've seen this in the healthcare space. I'd be very interested in how they would do this in any other space other than healthcare, because it's one thing to put it in a patient room and put a sign on the door in a process, do not enter, sterilization in progress. It's a whole another thing to put it in an open office floor concept and hope that a tenant doesn't decide to come work at night and you've got UV lighting on and now they're getting a sunburn. I mean, that would seriously concern me as a facility operator. So it'll be very interesting to see if people start to do this. Now, what I have heard is some folks using, I think it was called deflective um, UV sterilization, where they bounce the UV light. I'm not 100% sure about that. That's something I'm researching more, but I've read about it and it'll be interesting to see if that kind of mitigates the severity. But I don't know how it would, because the whole purpose of UV is essentially irradiating the pathogens. And unfortunately, that also irradiates skin as well. Filtration. Now, you've heard about HEPA filters. Just so we're clear, HEPA is the filter, MERV is the rating of the filtration. I see a lot of folks who will say MERV filters and HEPA filters, and it's not MERV filters, it's MERV whatever is the rating. So essentially, as you go higher on the MERV rating, your ability to filter particulate matter increases. However, it also increases the filtration of air and the restriction of air, and this causes pressure drops, sometimes very, very large pressure drops. So as airflow is impeded by the filters, these fan systems are going to have to work even harder to maintain discharge static pressure. And we all know in the plan and spec environment how notoriously undersized systems can be. Systems will get undersized, they will barely be able to handle design days anyways, and now we are introducing a pressure drop that they were not sized to deal with, and we're going to see units that on design days cannot maintain the environment, and on non-design days are operating at least on the fan side at design day loads. So this is going to increase fan energy, and ultimately it's going to reduce the total CFM capacity of airside systems, which actually causes some challenges for the ASHRAE recommendations. Now, when you are implementing a filtration-based strategy, you need to account for several operational costs. I don't see people talking about this quite enough, in my opinion. First, the higher you go on the MERV scale, the more your system will experience a pressure drop across the filter. This is going to result in higher utilization costs, both mechanically and electrically. Remember, we're not just increasing our utility costs, but we're actually increasing the wear and tear on our equipment, and we are going to prematurely age our equipment. We're going to have to increase our PMs, our preventative maintenance tasks, to account for increased run hours. Additionally, you will find that increased filtration capabilities come with, guess what? Increased particulate capture. Now, this is going to result in more frequent filter changes, especially when used in combinations with strategies that increase outdoor air intake. Because if you aren't cognizant of AQI, the outdoor air quality, and you're bringing in more air, then you're going to find yourself having a lot of particulates hit your filters, which is going to increase filter changes. Excuse me. So, key points. One size does not fit all. This is not the end all be all. So you can't just do MPBI and call it a day, or ultraviolet and call it a day, or filtration and call it a day. You use these strategies in conjunction with one another to implement a system that addresses IAQ issues based on perceived risk. So, one of the concepts when I was getting my master's in cybersecurity that I learned was this acceptable risk concept. So, basically, you have risk, right? And risk is this square here. And you have a threshold of acceptable risk. So, we're just going to call this ACCR. And anything below this is acceptable, but anything above this is not acceptable. So you look at what level of risk are you willing to accept, and unfortunately, without diving deep into each one of your businesses, I can't tell you exactly what that would be, but essentially you look at what could go wrong. If you did not deal with IAQ, could you get sued? Could litigation happen? Could you be held at fault for not properly handling life safety issues? What would that potential cost be to your business? And then you implement mitigation strategies based on that perceived cost of that risk. So you basically price up the risk. You say, okay, well, we have 1,000 tenants or 1,000 occupants. If we had a lawsuit and it cost, X dollars, let's just use simple dollars here, $2,000 a tenant or occupant. So 1,000 times 2,000, 2 million. So our risk threshold's 2 million. We think there's a 20% chance of that happening. So in reality, we're 400,000. And now we have $400,000 of risk we need to mediate. And based on that $400,000 of risk, we can use XYZ technologies, and that will mediate the risk. And so that's kind of how you go about calculating and approaching risk. That's a common strategy for risk mitigation evaluation. So IQ is a process, not an event, and iteration is better than ideation. Instead of just sitting there thinking, man, filtration sounds like a great idea, but man, we would have to do all this stuff. Just doing little pieces. If you simply go and implement MERV 11 filtration, that's better than MERV 9 filtration or no filtration. If you go and implement UV on some of your systems or MPBI on some of your systems, that's better than none of your systems. Now, if you're asking me where I would focus, which some of you asked in the survey questions, I would initially focus on airside systems that serve spaces, not common areas. And here's why. Remember that I'm going to back up a little so I have some whiteboard area to draw here. Remember that little drawing I showed you of the supply and exhaust mixing? Well, in a lot of atriums, how well does the air mix? Well, some of them have the airside supply at the top of the atrium and it just blows down. Some of them have the return in the side of the wall and it takes it through there. In that case, it's mixing a little better. In average, the common spaces do not mix as well as office rooms, conference rooms, etc., because those are more enclosed spaces. So if I had limited money and I was focusing on something first thing I would hit are the airside systems that serve conference rooms, offices, etc., spaces where people will be for a prolonged period of time and potentially be grouping together. The likelihood of people standing in the atrium grouped together for a long period of time is not as likely as people standing in a conference room being grouped together. So that's my mentality and how I would think about where do I prioritize implementing some of these IAQ strategies. Okay, let's continue on. So, new strategies for COVID 19. Now, ASHRAE has released several strategy recommendations. I want you to focus on that word recommendations. Everyone is kind of issuing recommendations right now for COVID 19. Not a lot of people are saying this is required because the jury still seems to be out on what exactly is going to impact air quality and reduce viral spread. So the primary strategies we're going to focus on are outside air intake changes, humidity thresholds, and building flushes. Now, I will send this to you all after the fact, but if you haven't visited this site, this is the link you should go to. ashrae.org/technical-resources-resources. If we have time at the end of this presentation, I'll take you to the site and I'll show you how to navigate it from my perspective, because there's a lot there and I feel like you could probably get lost, and there's a specific way I navigate it. All right, so outside air intake changes. On most systems, ASHRAE is going to recommend that you drive as close to 100% outdoor air intake as long as it does not penalize energy, also known as increased utilization and demand. Additionally, ASHRAE is going to recommend disabling demand control ventilation due to the variability of outside air intake when linked to CO2 levels. All right. The addition of the recognition of the energy impact associated with 100% outdoor air intake, in my opinion, is good. They didn't really have this originally. Now, in situations where pure outdoor air, like Louisiana or Florida, is going to cause a lot of utility spend impacts, then ASHRAE is going to recommend you drive outdoor air based on 62.1 and utilize MERV 13 filtration. Now, this is where, in my opinion, some modeling is going to come into play, or some calculations. You have to ask yourself, will the MERV 13 pressure drop be more impactful than the increased moisture load of humid outside air? In some cases, excuse me, geez, you will have capacity in your central utility plant to handle the increased enthalpy load of outside air. In other cases, you may have the capacity in your fan systems to handle the pressure drop of MERV 13 filters. Only you know your building and your systems and what they're capable of. So you'll have to model out, can we afford a 1-inch water column pressure drop? Or can we handle a reduction of delta from 12 degrees to maybe 8 degrees across the coil because of the humid outside air? You need to think about this prior to going and implementing this. The important point is getting fresh outdoor air in there to kind of deal with what's going on inside the building, which is that viral buildup. But how you approach that is going to be based on your individual system's capacities. Humidity thresholds. So studies show that humidity levels between 40 to 60% assist in the mitigation of viruses. Basically, how this works is that the viral droplets at 40 to 60% humidity or relative humidity, they lose their moisture and increase in their salt content. And then this inactivates viruses in the air, right? It causes the viruses to become inactive. So that's why you're seeing this 40 to 60% relative humidity range recommendation is because of that study right there. So the ideal target is 60 to 40. And you can see as you drop below 20, that's like critically bad. As you start to go above 60 into that 80 range, depending on temperature, that can be very bad. Remember, this is relative humidity. So the humidity is relative to the temperature, and the moisture content is relative to the dry bulb temperature as well. So 80 degrees at 60% is much more grains per pound of dry air, of moisture, than 70 degrees at 60%. So understand that dry bulb has a factor, or temperature has a factor in this calculation as to how much moisture energy is being introduced into the building and into the airstream. All right. So, in order to implement these factors or thresholds, you need to factor in several strategies. First, can you even sense the humidity levels? I mean, if you don't have humidity sensors or they're not accurate, then that's kind of the first thing you need to remediate. And so, I think you will see a lot of folks starting to take this seriously because humidity not only has a direct effect on comfort, but based on a lot of studies, it has a direct effect on virus mitigation. Second, can you dehumidify the air? The reality is, at least here in the United States, at the macro level, most of the geographies have an excess humidity problem throughout most of the year. We have very few parts of the US at least that have uh, a dehumid or a humidification issue, meaning that the air is so dry that you have to humidify it. Most of the US in most of the year is dealing with a dehumidification, 60, 70% relative humidity. Third, and this is something I don't hear enough people talking about that we need to be considering, especially since we are rapidly approaching the winter time, is can you humidify the air? So as we enter the winter season, this is time to go check those Nortec humidifiers and actually make sure they work. Because I mean, we all know how many buildings have a humidifier installed in the airstream that they've literally disabled and have never run because it's a pain in the butt to maintain and it's a pain to control because it can easily overshoot the humidity values. So, can you humidify the air? You need to be cognizant of this, especially if we are going to be implementing more outdoor air centric control. And finally, building flushes. So, this is the next big thing, which is building flushes are kind of a newer introduction to sequencing. If you've ever done a lead project and you've done that 24-hour flush to kind of get rid of the VOCs from new carpet and new flooring that lead requires, then this should be somewhat similar to you. Basically, the premise is that you can mitigate the viral load within the air by flushing air from the building before occupancy and after occupancy. Now, in the standard or in the recommendation, it says, first off, you need to do this for about 2 hours before and after occupancy or 3 air changes worth of space volume. That's a very important thing to note because as we start to concern ourselves with outdoor air humidity, this 3 air changes worth of space volume will help us find some ways to get around that humidity that we may be bringing in the building. So you need to be able to operate your HVAC systems with maximum airflow before and after this occupied periods, or, right, we can implement a sequence that gets us 3 air changes worth of space volume prior to occupancy and post occupancy. Now, many buildings in a geography that doesn't play nicely with outdoor air, think Louisiana, Florida, in the middle of the summer, right? Highly humid, highly hot environments. Because of this, you can actually run your outdoor air dampers at a lower percentage as long as you have a way of measuring outdoor airflow intake. So if you have flow sensors at the outdoor air damper and you're sensing outdoor air flow, and those sensors are actually accurately calibrated, Then you just basically do some logic math with an accumulator in your programming and you calculate that up. And once you have hit that threshold where you've brought in enough airflow, then you can start to lower back down to ASHRAE 62.1 standards. Now, this may require the addition of some flow sensors, some basic programming in the building automation system to drive the flush mode until this outdoor air volume has been satisfied. So I like to think of this as like a optimal start or night purge mode, but just for outside air instead of temperature. All right, so the key points on this: humidity, temperature, and airflow are all factors in COVID-19 mitigation, at least based on the studies. Understanding the enthalpy load when introducing additional outside air is critical, because the last thing you want to do is start to highly saturate the inside of your building, and it's going to be a really difficult problem to overcome once you've built up that enthalpy load. It's kind of like how I tell my wife, hey, let's turn off the air during the day when no one's in the house. I'm like, that's a horrible idea because it's going to get so humid in the building, in the house. It's not going to be hot, it's just going to be humid, and it's going to take a lot more effort to remove that humidity than to just keep the house a little bit cooler during the day. And air changes can be used in lieu of outside air in some cases. All right. So that brings us to, oh, wow, that took longer than I thought, 12:50. So I'm going to give you all one utterly amazing fact. It's absolutely amazing. You'll be shocked when you learn it. And that is that 100% of questions that are not answered during the live question and answer session do not get answered. So if you do not ask a question, then it will not get answered. So now is the time for you to ask questions. Any question you have, anything that I can answer for you, it is time now. And I will chill here until you are done asking questions. Alrighty. And I have some questions already in the queue. Do I have any air flush graphics I can show? Air flush graphics, like how it works? Help me understand what an air flush graphic would be. You're talking about programming logic for air flush? While I wait for you to answer that, we are seriously considering upper air systems for conference rooms, lunchrooms, etc. Yes, that is something. So there are some folks who are doing space-based sterilization, and they're putting them into the spaces. That is one strategy, slightly more costly. But if you can't get a proper mix within the space, then it could work. All right. What sensor data would you consider trending at a higher rate during COVID-19? Humidity, temperature, outside airflow, air changes, but that's going to be a calculated value. And if you have any way of occupant numbers, that would be really important. Basically, what I'm looking for from a data perspective is what data could I use if litigation comes against me? What could I use to show that I'm controlling to the recommended guidelines and I'm taking best in class action for mitigation? Because that will likely reduce a judgment against you if it shows that you were taking best effort versus if you did nothing and you had no data. That would not look good. It's kind of the old ice on the sidewalk question. Do you salt the sidewalks or do you not salt the sidewalks? And simply the fact that you're having that conversation means that you're cognizant of the issue. And whether you do nothing or do something, your cognizance of the issue is demonstrating that you were aware of it. Are there any jurisdictions in the US dictating COVID driven requirements on ventilation beyond 62.1? Not that I'm aware of, Jonah. Maybe someone on the webinar is aware of that. I personally am not. Um, I think that is going to. So here's the thing, you've got cities that people are leaving the buildings and not wanting to come back to the cities. And so anything you do that makes it more difficult for building owners is troublesome. But also you want to encourage tenants that the building's healthy and to come back in. So it's kind of a catch 22. XXCFM in the building today. We have turned over air 5 times today, something like that. Okay, so you're asking basically for a simple IAQ page. I don't have an example of that, Patrick, but it would not be terribly difficult to create if you can modify the graphics. It's more of, do you have the data to even populate the page, because a lot of systems do not have the data. How do I know if bipolar ionization is actually successful? There is no feedback. Absolutely right. Um, there is no feedback. There are studies, but I don't know who those studies are commissioned by. I am not a advocate of any technology. I'm neutral. So, Greg, I can't tell you. If someone figures out how to sense viral particles within the air and report on that effectively, they will be a billionaire. What value drivers do you use to explain the importance of IAQ to end users other than their air is healthy? So are we talking end users being occupants, or are we talking end users being property managers and decision makers? So answer that, and I will get back to your question. I heard that UV lamps are in very short supply. That is having an impact on deploying any of these in systems, says Ernie. Yes, UV as well as filtration, although filtration is now starting to catch back up. But yeah, UV lights, components for MPBI, I've heard, are starting to become more difficult to come by. It's like anything right now, supply and demand. So you're going to see increased prices, and it's just going to be difficult. That's why I say, honestly, that can be very freezing. That can make you freeze and be like, man, ah, can't do anything. So the thing is to just do a little. I mean, if you take little baby steps, then at least you're making a little bit of progress. I was logged in with my phone, but have switched, mentioned airnow.gov, but honestly, can you use current AQI for calculations, or is there a better reference for finding that particular measurements to use? Personally, and I don't know if they have it, weather API. I think it's, here we go. I don't know if they have IAQ though. This is the API I like to use personally. I don't know if it gives AQI data though, is what I meant to say. If it does give AQI data, then you would just grab it. I mean, there's UV index. So let's see. I'd have to dig into it, but if they have AQI, then this is how I would get it. I would grab it via the API, pull it in as a JSON feed, and then parse it in as a variable into my building automation system and use it to basically go into a comparator and say if AQI is greater than X percentage, then do not enable economizer. Any additional tips for building operation with low occupancy during COVID? Yes. So first off, get very granular on your schedules if you can. If your equipment is set up as such that you can schedule individual floors and individual zones, do that. Use standby modes for spaces that are unoccupied. Reducing airflow within spaces that aren't occupied and aren't being utilized is going to go and reduce the thermal load on your building, which then is going to reduce the utilization of your central utility plant. Consider also turning off lights. Consider also going and if buildings are heavily windowed, can you put in some temporary shades or anything that block thermal gains or thermal losses via windows? Those are all things that you can do. I mean, I'm sure you wouldn't be surprised, but a lot of people are surprised how much heat can be gained by southern exposed windows. And if the building's not occupied, then there's no reason for those windows to basically be allowing thermal energy to pass through them. Prior to retrofitting the HVAC system, how would one analyze or monitor the air quality of a building? Well, Keith, it really depends on what is in the building. I get asked this quite a bit. How do I how do I determine that? And the challenge is if you have a pneumatics building, that's going to look completely different than if you have a DDC building. Or if you have a DDC building, so direct digital control building automation system from 2000, that's going to look completely different than a 2010 system. And that's just building automation and the sensing capacity and inputs and outputs, right? Um, that being said, if you're looking to do this, and let's say you have no data sensing capacity, then you can use like hobo sensors, etc., for doing IAQ logging. You would go and install those sensors, and they would basically be data loggers. I've done this a lot with museums when they were getting ready to bring in an exhibit and they had to prove that the IAQ was satisfactory for bringing in the exhibits. Because a lot of exhibits, especially if they're older kind of artifacts, they have guidelines on the specific temperature and humidity levels that need to be maintained for the museum. And so you'll have to put in data loggers and do an independent verification of the IAQ prior to bringing that exhibit in. So that would be my approach. Matthew says, the end user being decision makers. So what I would do is I would show them just what I just showed you a little bit earlier when I was doing that risk calculation. It's all about a risk calculation. They have a certain, excuse me, amount of capital, both operational capital as well as just budgetary capital that they can apply to their building. A lot of people, especially in the CRE space, commercial real estate, are finding that they do not have cash flow because they do not have tenants or tenants have reneged on their um, leases. So, what you're doing here is you basically are saying, what is the risk associated with not mitigating these issues? And then what is the cost of mitigation? So, it becomes a financial conversation. In my opinion, with that level of person, it should almost always be a financial conversation. Just like cybersecurity, you look at what the risk is and the mitigation strategies that you can utilize, and then make a decision. Ernie says MERV 13 filters are 1 to 2 months out. Yes, unless you buy them through Amazon. I just bought some for my house. But probably not the size you need in your defense. So, do you know of any cost-effective ways to measure ion presence from NPBI to determine if the ions are reaching the space? I do not. Um, if anyone does know, feel free to let me know, but I do not. And the folks who produce MPBI um, are probably not incentivized to share that information. I'm just taking a guess. with MPBI, what are the added maintenance items that affect the building facilities budgets? That's a good question. I haven't been able to find out that data. I've looked for it. I haven't been able to find it. So for someone who utilizes MPBI right now, be very interested in knowing what you're experiencing. Because personally, everything I've read is like, it's maintenance free. You don't have to do anything. You just install it and it runs. It's like a sham wow. Um, but I don't know if that's true. It might be true, might not be true. I don't have one installed in my house, so I wish I could tell you, Cody. Is it possible to introduce humidifiers with an eco-friendly agent that would seed during unoccupied hours? Yes, but why would you do that? Just out of curiosity. Um, how are you using the Open Weather Map API in your BAS programming? Basically, what I do is I write a C# program that allows me to take the API, parse the JSON, and push it into a backnet stack I've developed. If I'm using like a Tritium system, then I just use their SDK, and you can just parse the. Then it's Java, it's not C# anymore, but you just parse the net library and read the API and parse the JSON and just pull it right into a numeric object. Yeah, I mean, you could do that. Personally, you could create spot mold issues if you're. So, is it possible to introduce humidifiers with an eco-friendly agent that would seed during unoccupied hours for surfaces? You could do that. You could potentially introduce spot humidification issues that could go greater than 80% relative, which could cause mold issues. So that is possible. I personally prefer to have humidification in my Airstream and use it as part of the startup process, and then maintain it throughout the day and naturally let it clear out at night. All right, man. Woo! Churn through all the questions. So, what other questions do you all have? Feel free to just type them in and okay, so Heather says we have MPBI in our house and it makes the filter super dirty the first month and much less than our old normal for the next month. Proof that it is collecting particles. We sleep better for sure. In Colorado, we have a local filter guy that could produce in days the MERV 13 filters. So, yeah, that's pretty cool. I would understand why. Yeah, if it's neutralizing stuff and then it's getting captured because it's binding with the particulate matter, so that it's now being caught by the filtration. Yeah, that would make sense. I heard that MPBI doesn't affect dander and stuff like that, though. It just affects particulate virus stuff. So. Will I email the slides? We don't really ever give out our slides. However, this video recording will be available for you all to view on our website shortly after. Yeah, so Heather, like I said, I could be wrong. I'm just going based on what I researched because I am far from an NPBI expert. Hope you all learned something. I honestly was a little nervous going into this because I felt that I needed to provide something that wasn't already being said by everyone else. And so I'm glad to hear that you all found value in this. So thanks. And yeah, and I appreciate you all filling out the questions prior to the presentation. It really allowed me to flex in the topics that we covered. So I'll remain here. I know we're a little bit over our time. But you all know who have been on our webinars before. I like to stay. I'm going to lower my standing desk here because I'm getting tired of standing. So you're going to see me moving. Oh, I got shorter and now I'm getting taller again. It's amazing technology. All right. Um, Anywho, I'll chill here for another like 10 minutes or so, see what other questions you all have. Please fill out the post webinar survey. Let us know what you liked, what you did not like, and what topics you'd like us to cover in the future. Oh, that's right. I said for those of you who stuck around, I would show you all this. ASHRAE.org/technical resources I mean. So basically, what we do here is I like to go to buildings, and then I like to go to commercial, and then I like to click on right here to start, and you just kind of read through. I recommend you read this like once every 2 weeks because they update it. Talk through kind of all the different standards. If you click on a standard, it will actually link directly to the standard so you can read it. So you can read the ASHRAE 55 or the ASHRAE 62.1, which I know they're a pain to read. I know they're so boring, but I really recommend you read through them all. I mean, there's 60 pages, and you'll be like one of the few people who have actually read the whole ASHRAE 55, ASHRAE 62.1 standard, and then you'll be able to be in meetings with people and be like, no, actually, that's not what the standard says because I've read the whole standard. So there's nothing like being able to have that in your back pocket in case you get into some heated conversations. But it's nice. It takes you through kind of how all this works. Talks about different strategies based on system types. I didn't discuss decusant wheels, but enthalpy, also known as decusant wheels, and heat wheels, things that expose themselves to the return stream and then re-expose themselves to the incoming supply stream, they want those disabled. Oh, wait, no. They don't want them disabled anymore. See, this is why you've got to read it repeatedly. They changed it. It used to say that you wanted these wheels disabled. Now it says that you should keep them in operation. Well, consider whether you keep them in operation. All right. So if you know sensors are installed wrong, what steps would you take to remedy the problem? Well, it depends. So, like, if you're the contractor, then you should fix your installation. But if you are service or your facility team, which I know you're on the facility side, then it depends on the sensor. Usually, I will go and hopefully there's been some excess wire left, but usually there's not. So I'll go use the existing wire as a pull wire for new wire, and I'll rewire them the way they're supposed to be. You have to think about what is the dependency on the sensor. So there's two types of sensors. There are data sensors that are just, hey, this is a data point that says, hey, this is for your awareness. And then there are actual control sensors. So for example, on a VAV box, on like a reheat VAV box with electric reheat or hydronic reheat, typically you are controlling electric and or hydronic reheat to space temp, right? So your control variable is space temp. That being said, a data or just a input point would be discharge air temp. So discharge air temp tells you if the heat's working, but it doesn't control anything. So if I had to prioritize, I would fix the zone temp sensor location first, and then and only then would I fix my discharge air temp location. So think through it from that process. Is this sensor going to impact the controllability of the system? If it is, that's the sensors I prioritize. If it's simply a data point, then I'm going to look at that kind of after everything else has been dealt with.